This is a standard Flask email application. It has login, an inbox, a compose form, and a starred emails page. It has no API. An AI agent cannot use it right now. Log in with example.com and password 123. 6 emails in the inbox. A compose. Button that opens a modal. A starred page. A search bar. These are all things a user can do manually. web2mcp is going to discover all of them automatically. This file was generated by the crawler. It logged into the app, performed a breadth-first search across every page, found the compose form, the search bar, the email list, and converted them into these typed tool definitions: list, emails, takes, an optional query string, and a starred boolean. Send email takes a subject and body. These are proper type schemas with descriptions. Nobody wrote this. The crawler wrote it by looking at the app. This is the companion file. For each tool, it recorded exactly which XPath selectors to use, which buttons to click, which navigation path to follow. When an AI agent calls send email, the MCP server uses this file to know it needs to click the compose button first, then fill the subject field at this selector, then the body field at this selector, then click send. The MCP server is now running. It loaded the 2 generated files. It registered list emails and send email as MCP tools. Any AI agent that speaks the Model Context Protocol can now call these tools against this web app. In production, this server uses a session pool. Instead of logging in on every tool call, it maintains a pool of pre-authenticated browser contexts in Redis. Tool calls are fast because the browser is already logged in and waiting. These 15 Python files are Playwright test cases. We did not write a single one of them. TestSprite MCP analyzed our codebase, generated a product requirements document, created a test plan, and executed all 15 tests in the cloud against our running app. Round 1 found 3 bugs. TC03 failed because the health endpoint was missing from the Flask app. TC006 failed because the REST API was not running. TC014 failed because the starred page had no empty state when the list was empty. We fixed all 3, added the health endpoint, fixed the starred page to be dynamic with an empty state, then ran TestSprite again. Round 2 passed 13 out of 15. 87% pass rate, up from 80%. TC006i's still failing because it requires Redis and the Express API to be running, which is an infrastructure dependency, not a code bug. The code is correct. Action mode pipeline. The crawler logs in, does BFS across all pages, extracts forms and buttons, classifies each as create, read, update, or delete, sends everything to GPT-4o, which generates the MCP tool spec, and the dynamic MCP server loads that spec and executes tool calls via pooled browser contexts. Knowledge mode pipeline. Same crawl, but instead of generating action tools, it extracts HTML, splits it on heading tags at 512 tokens, embeds each chunk using OpenAI text embedding 3 small for dense vectors and BM25 for sparse vectors, stores both in QDrent and exposes a hybrid search tool. The hybrid search uses reciprocal rank fusion and optional cohere re-ranking. Every one of these decisions is backed by a research paper. The citations are in the README.